I have 3 more examples, and I'm determined to get through those here in the next video. So, in this one, locate the absolute extrema on the closed interval. So it's just like the last one we just did. I am going to go ahead and find its derivative first, but before I find the derivative, I'll rewrite it. Please make sure that you are using proper notation when you're rewriting it. Now we're taking the derivative and denoting it as g prime of x. So I get 1/3 x to the negative 2/3. It's going to be a little bit difficult to think about, so what I'm going to do is rewrite it in terms of a fraction. And then I'm going to determine where does the derivative not exist or where is it equal to 0. Well, it's never going to equal 0 because I have a 1 on the top, but it will, the derivative does not exist. And where does it not exist at? Well, that would be at 0. So the derivative at 0 does not exist because it gives me 0 on the bottom of the fraction. So I need to determine where are those absolute extrema. I am looking at this interval, so 0 is within that interval. So I need to test the y value at -1, the y value at 0, and the y value at 1. What are those heights? Well, I will plug in -1 for my original, and I will get -1. I'll plug in 0, and I'll get 0, and I'll plug in 1 to get 1. So my absolute minimum is at -1, -1. My absolute maximum is at 1, 1. And that's just from this. This is the x value, this is the y value on us. This 0, 0 isn't anything but a critical point. The next one, in order to do this absolute value, we know absolute values make a v. So I need to know if that v, where that corner takes place, is within this interval. The best way to do this is just to strictly look at a graph. And I'm not even going to take the derivative of this function. I'm just going to look at a picture. The worst case worst, when we can't take the derivative of something, we need to just go ahead and sketch the graph of it. Well, what does this look like? I know that this value is telling me to move the graph up 3. And this minus in front of here is telling me that the v is upside down. And this one is telling me to move it 3 to the right. Using those rules from algebra, I can now determine that I have a graph that looks something like this. Now remember, we're only concerned about this closed interval. So I'll be checking the endpoints of -1, and I'll be checking the endpoints of 5 for absolute max and mins. But I also need to check this value, which is 3. When I plug in, and I can actually tell that there's a maximum right there at 3, and those other two have to be absolute minimums, but we'll go ahead and plug in those values. When you plug in -1 here, we get -1 minus 3, which would be a -4. Absolute value of 4 is 4, so 3 minus 4 is -1. When I plug in 3, 3 minus 3 is 0, 3 minus 0 is still 3, and I plug in 5, 5 minus 3 is 2, 3 minus 2 is 1. So what does this mean? Well, this one happens to be my absolute minimum. It's the smallest value. So I'll write that as -1. -1 is my absolute minimum. And then 3, 3 is my absolute maximum because it is the highest height. The 3 is the highest height. The last example of what I'm going to do is just take the derivative quickly. I may not get this finished. We can discuss this in time if I do not get it finished. So I've got bottom times derivative of the top, which would just be 1, minus top times derivative of the bottom all over bottom squared. When I go ahead and simplify this, I get t minus 2 minus t all over t minus 2 squared. Those cancel and I get -2 over t minus 2 squared. This is my derivative. The only critical number is right here at 2. So when t equals 2, there's a critical number. But look at my interval. This falls outside of my interval. Outside of interval. So I do not even have to check it. I only have to check my endpoints.